In this course, we will be learning about the tool HYPERMESH and the solver RADIOSS. HYPERMESH is a universal preprocessor that is widely used in the industry. RADIOSS is a flavor of NASTRAN and is the most preferred solver for structural analysis. This course features 60 hours of classroom sessions, 200 hours of practical sessions, topic-wise online tests, 60 hours of industry-oriented project, and special sessions for interview preparations. Module 1 will consist of geometry preparation and meshing techniques using HYPERMESH. This will include geometry preparation of auto and aero systems using HYPERMESH, under which we learn about the geometry preparation for the fender of a car, geometry cleanup for the center pillar of a car, and the geometry preparation for the wing panel of an aircraft. We will later move on to 2D meshing techniques for auto and aero systems using HYPERMESH. This will consist of meshing of BIW parts for both auto and aero using auto meshing techniques, and meshing auto and aero components for crash and durability analysis. We will later move on to 3D meshing techniques for industrial systems using HYPERMESH. This will consist of 3D meshing, structured meshing consisting of brick or hexa elements, and unstructured meshing consisting of tetra elements. We will also learn about 3D mesh generation for industrial systems. At the end of the module, you will have assignments and evaluations on geometry and meshing. The topic for Module 2 is Structural Simulations using RADIOSS. Under this, you will learn structural analysis for aero and automotive systems. You will learn industrial approach to design and validation, introduction to FEA and CAE workflow, and introduction to strength of materials. You will then move on to linear static analysis, both theory and practice. Here you will learn about the design validation of an automotive gear shaft using structural analysis, identify the failure mode and redesign an engine mount using linear static analysis, and design a connecting rod for strength using stress analysis. You will also learn how to process results using HyperView. You will finally learn how to interpret and document results. Mesh generation techniques for crash analysis. In Module 4, you will learn thermal and dynamic analysis using RADIOSS. You will be introduced to normal modes of vibration, under which you will learn solution methodology, which consists of eigenvalue, eigenvector, and Lanczos method, normal modes analysis of mini racing car frame, vibration analysis of a rotor, natural frequency estimation of a truss bridge, and modal analysis of a brake disc. You will then be introduced to thermal analysis, wherein you will be doing a thermal analysis on a friction ring.